Okay, this is another Unit 2 mechanism. This is nucleophilic substitution. This always happens between a haloalkane and a nucleophile. 3 nucleophiles you need to be able to do it for are OH-, CN-, and NH3. So I'm just going to show it very generally. We've got a carbon with 3 things coming off it. I'm not even going to fill them in, and that's joined to X, where X is some sort of halogen, and as a result of that, that means that this carbon will be delta plus, this halogen will be delta minus, which is where the site of the nucleophilic tack comes from, this delta positive charge here. So I will show all 3 mechanisms for you here. Here it is. This is with OH-, and the reagent for this is cold aqueous sodium hydroxide. The nucleophile backside attacks this delta positive carbon, and it pushes electrons onto our halogen. So our product will look like this. It will be the alcohol we will have formed, and we'll have some X- will have fallen off there, and you can draw the lone pair on it if you want to. So that's the first one. The second one, which we said we had to be able to do, was when your haloalkane reacts with CN- as the nucleophile, and it's exactly the same as before. We've still got a delta plus on the carbon, a delta minus on the halogen, which makes this our nucleophilic attack site, nucleophile attack site. So the nucleophile attacks the carbon, pushes the electrons off onto there, and we make this time a nitrile compound by this reaction, and we still generate some halide ion here. And the final one, this is the one people always mess up because it's a 2-step mechanism. This time we're going to start off again with our alkyl halide, and we're going to attack with ammonia as our nucleophile this time, and just as in the other 2 cases, the site of the nucleophilic attack is this delta positive carbon caused by having a electron withdrawing halogen attached to it. And what we're going to do, we're going to backside attack again onto that carbon, push electrons onto our halogen, and this is the step that people always find difficult to remember. Because our ammonia wasn't charged like these other 2 nucleophiles, by giving up its lone pair, this nitrogen will have become positively charged, and we have to do something about that before we've finished our mechanism. So here is this positively charged intermediate, and don't forget we've generated X- here. Now, to get rid of this positive charge, we just add another ammonia molecule into the mix. So here's another ammonia from our reaction vessel, and what's going to happen is the lone pair here is going to pinch one of these hydrogens. That will push the electrons from that hydrogen-nitrogen bond onto the nitrogen and neutralise the positive charge, and we'll end up with an amine and an ammonium ion here. So the ammonium ion and the halide will form some salts, and so we'll have, if it was a chloride, we'd have ammonium chloride as our byproduct. And that's nucleophilic substitution.